And hello everyone, welcome to your next pointer tutorial. In this tutorial we'll be looking at dynamic memory. Alright, so let's just clean up a bit here. Now, in the previous video I did mention about passing in pointers to functions and whatnot. We will get to that in the next video. But in this video I want to play a little bit more with just general pointers. Alright, so let's go here. We say int p. This is a pointer because we're using an asterisk. And here we can say is equal to a new int. This is an optional, but this says that we just want a new integer to point at. Cool. What will happen if we try and print out this p address here? We get this right here, the address. What happens if we try and dereference it? We get 0. So if we do this, it stores a 0 by default inside of here. We can change what it stores by going asterisk p is equal to and then what value you want to store there. So let's say 69. Nice. So here we're saying dereference p and at that value store 69. Now if we were to run that, we'll get 69. And here we could also get an example where it's just address. So the address and then we get 69. So by dereferencing and then equaling, we can change the value stored inside of that address. We don't want to reset the address itself, but we can store a value inside of that address. If you want to free up some memory, you could also delete a pointer. This deletes the place where it was in the memory. It does not necessarily delete the pointer itself, but this does free up some memory. Generally, you do not want to manage memory yourself. Managing memory yourself is about never a good idea unless you're working with C and really need to manage memory yourself. Generally, let C++ manage the memory for you. But you can do this and this will delete p. If we do this, we'll get a memory address, but then it will have a random value in there because this value, it doesn't exist anymore. We deleted it. So it still has the address, but it doesn't have the content of it anymore. So we go here right before the delete. You'll notice the address is the same, but what's inside of it changes. So we delete what's inside of this address. Of course, if you want to request memory for it again, you can just say p is equal to new int like this, and this will request memory for it again. Now if we do this, it will have new memory requested for it. Now you can also go int, and let's go asterisk p is equal to null, and it should be int. This means the value or this pointer is null, it's nothing. Now we can say x is equal to new int 5. Like this, we can actually store a specific value on the same line. And then of course, we can just see out p, and this should be p, not x. P, and we can go p, and then we can also dereference it. Let's first see what we get if we do null. We get 0, so the address itself is 0. And then we get a segmentation fault. That is because there is no value in null. If it's set to null, there is no memory address here. This is usually when you want to later on add a new value or add a memory address, but you don't want to add a memory address right now. Then you can make it equal to null and it won't have a memory address yet. Then here you can create a new int and you can give it a value if you want. It can just be like that and add a value later, or you can do that and give it a value now. But running it now, we get this. And my bad, this is the size. And of course, if you want to delete the array, you can just say delete and then an array symbol and then your variable. And this will delete it once again. Run it, we'll get this because it has been deleted. Generally, you do not want to manage memory yourself. This tutorial is just to show you can manage memory yourself if you wanted to. But I recommend, if you don't have to manage memory like this, don't. Don't delete when you don't have to delete. Only if you need to really optimize, manage it yourself. But generally, do not delete memory. And yeah, that is that. Thank you all for watching. I hope you all enjoyed, and I will see you all again in the next C++ tutorial.